This is section 5.4, factoring trinomials, and we're going to look at factoring trinomials of the type x squared plus bx plus c. But before we factor, let's have a brief recall moment of multiplication of binomials. And say we have x plus 2 times x plus 5. We would use the FOIL method for multiplying these, multiplying the first two terms together. X times x in this case would be x squared, and that's the result of the first two terms of our binomials. Next, we multiply the outside terms, the O, which in this case gives us a 5x. We multiply the inner terms, which gives us a 2x, and we add those together if they're similar, and they are here, to give us a 7x for this example, but it was the result of adding our outside and our inside terms together. And then we're not quite done. We have one last step. We'll multiply the last terms together. 2 times 5 is going to give us 10. And that last term was the result of a multiplication. Well, this was multiplication in this direction. We're now going to start with this and ask where did it come from with the opposite of multiplication, which is division, and we're calling factoring. So that leads us to the relationship that I just laid out for trinomials of this type. When you have a leading coefficient on your highest degree term, when you look at this number, the coefficient, you're looking for the addition of those values from the binomial, and C was generated from the multiplication of those values. That's where the last term came from. This was the outside and the inside result. The other thing that we need to take a look at is this sign here. If it's positive, it means both of our binomials had the same sign. If it's negative, it means one was positive and one was negative, and we'll explore that further with some examples as we go along. So let's get started. The coefficient is 1, so our game plan will be to look at what multiplied to give us 2 and add it up to give us this middle term of 3. You can break down your factors of 2, and here's where the sign analysis comes into play. If this is a plus sign, it means the factors of 2 had to be the same sign. Are they both positive or both negative? We will look here to answer that question. If this is positive, it means the factors of 2 were both positive. Well, 2 is prime. We only have one choice. There's only one way to get 2 with multiplying two numbers. It's 1 and 2. Where did the x squared come from? That was our first term. X squared came from an x times x when we multiplied the first two terms together. Our second term in each of the binomials are both positive, and we really have only one choice. So the choice is the 1 and 2, the obvious. And then we test, is this where this trinomial came from? When we multiply our first two terms, we're okay. Outside, here's a 2x. Inside is a 1x. Those would add up. And we could have tested them here. 1 plus 2 does equal 3. And doing our FOIL, the last term does verify that we have what we started with. So that's the factored form of this trinomial. Let's look at the next one. When you have a coefficient of 1, you can use the procedure of what numbers multiply to give you negative 10 and add up to give you negative 3. Because it's a negative 10, that tells us one of them is negative and one of them is positive. How would you multiply two numbers to get a negative 10? Well, we have a couple choices. It could be negative 1 times 10. And to check that, if you add these factors together, negative 1 plus 10 gives us a 9. We're looking for a negative 3. Not the case, so we will not accept that as our possibility. Switching the signs, yes, we could have a positive 1 and a negative 10 multiply, give us negative 10, but the only thing when we add those together, 1 plus negative 10, just changes our sum from a positive to a negative, so it's still a failure. How else can we get a negative 10 by multiplying two numbers together? We could have a negative 2 and a positive 5 would be factor pairs. Multiplying, we get our negative 10, and adding, if you check, negative 2 plus 5 adds up to be 3. We're looking for negative 3. We're very close, and the only thing that's left to do then is to switch those signs. Instead of a negative 2, let's do a 2 times a negative 5. That gives us the negative 10 we're looking for, and when you add those, 2 plus the negative 5 gives us ding, 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 the value that we're looking for. So we now have the numbers for our factor here, and so x squared minus 3x minus 10 factors into the following two binomials. This leading term is where the f, the first two term product, came from, which if we undo that, it must have been an x and an x. When multiplied, gave us x squared. We just found the pair that when multiplied together gives us the negative 10. We need a positive 2 and a negative 5. And if you finish off the FOIL method as a check, we know our first terms work. Our outside would be a negative 5. The inside would be a 2x. Adds up to be a negative 3x. And of course, our last term better be the negative 10. And it is. Next one, same thing. When your coefficient is 1 on your highest power term, you can look at the procedure of what multiplies to give you negative 3 or negative 6 and adds up to give you the 3. We have some choices. We have negative 1 and 6, 1 and negative 6. We could also have negative 2, 3, and positive 2 and negative 3. We're looking which one of these adds up to be the 3. Not here. This would add up to be a 5 when we look at adding those factors. This is negative 5. Adding here, we end up with a positive 1, and adding up here, we end up with a negative 1. We were looking for a 3. What's up? Well, there are trinomials that are not factorable. And so we would call this either not factorable, or our answer could be prime. It is not possible to break this down. And think about prime numbers. 3, for example, is a prime number versus 14, which is a composite number. 14 can be broken down into a prime factorization of 2 times 7, where 3 is prime and we're done. Well, we have the same thing in the algebra world with polynomials. It's possible that they just are prime. In this next example, the leading coefficient is a negative 1. It's not in the order that we're accustomed to. And here's another place where that division or factoring out a negative coefficient is handy. It's best if you put them in decreasing orders. We kind of get used to that method. So I'm not changing any signs. I'm keeping the sign with the values. This looks better. We have decreasing powers, but we have a negative in front. And to make life easier, get rid of it. Well, the get rid of it has to stay along. And to stay along, we're going to factor out a negative 1. Every one of these terms, I'm going to divide or factor out a -1, which changes the signs. Negatives cancel out, leaving an x squared. Negatives cancel out, leaving a positive 2x. Positive over negative is a negative. This result looks much easier now to factor. The important thing is what you factor out, if there's a greatest common factor, has to carry along, because at any time this should multiply to equal your original expression. So our mission here is always looking to see if you can break it down further. When you have a power higher than to the first, you should always be suspicious that you can break it down. And because our coefficient now is 1 and we're only dealing with here the trinomial within the parentheses, we can now use the procedure of what multiplies to give us -15 and adds up to give us 2. So we have some choices. We could have -1 and 15. We could have -3 and 5. And of course we could reverse those. -1 and 15 would add up to be a 14. That's not what we're looking for. -3 plus 5 gives us a 2. And we're spot on with that value. So we still continue with the negative. And whether you write the 1 or just the minus sign is fine. We're ready to factor this trinomial into a product of binomials. X squared was the result of the first two terms multiplied together. That would have been an x and an x. And the pair that give us the last term are these two factors. One is a -3, the other is 5. A quick check. Multiplying first terms, there's our x squared. Outside would give us a 5x. Inside a -3x adds up to be 2x, and of course the last terms. So this would be our final answer, including that -1 that we factored out in the first place to get it looking similar to what we are accustomed to as far as factoring. And it makes it much easier. In the next one, always a good idea to look for a greatest common factor, and this is the case. What's common between these three terms? There is a common 4. So to make it easier to factor, it's always best to look for a greatest common factor. Every term then is going to be divided by 4. That will leave us with a y squared. 4 over 4 leaves us with a 1y. 12 divided by 4 is 3 with our 0. Because we have a power higher than first, you should be suspicious of, can we factor this further? It is of the form of a trinomial with a leading coefficient of 1 on the highest term, I guess I said that already, which means we can use the strategy of what numbers multiply to give us -30 and add up to give us a -1. Because this is a negative, one of these factors has to be positive, one of them has to be negative, and you can list your factor pairs, and recognizing we can switch the signs. -1 and 30, if we add those, would give us a positive 29. We're looking for a -1. 2 goes into 30 15 times. That would add up to be a 13. No, that doesn't work. 3 goes into 30, so 30 times 10. We're getting closer. When we add those, we get a 7. 4 doesn't go in, but 5 does. So if I had a -5 times 6, I'd have a -30. When I add, I'm getting a +1. So close. And what that tells us is all we need to do is switch the signs, one positive and one negative. So we now have our factor pair. We factored out a greatest common factor of 4. It needs to drag along. Where did the first term come from? It came from each of the binomials having that term times itself to give us the y squared, so each one is y. The factor pair that we found that will give us the last term and add up to give our middle term is a +5 and a -6. A quick check. Your outside would give you a negative 6y. Your inside would be a 5y. They do add up to be a negative y. And of course, your last term better be the negative 30. And again, that important what you factor out, in this case, the greatest common factor of 4, needs to be part of your final solution because this should multiply to equal the original polynomial that was given. Well, we can have greatest common factors other than integers, and here's an example looking at the greatest common factor. Number-wise, it's 1, but variable-wise, it's t to the second. No problem. We'll get rid of that greatest common variable factor by dividing every term by t to the second power. T to the fourth over t to the second leaves t to the second. T to the third over t to the second, subtracting exponents, leaves an 11t. The t squareds cancel out, leaving a 1 times 24, or 24. It looks a lot better as far as factoring at this point. Because we have a leading coefficient of 1, we can look at what multiplies to give us 24 and adds up to give us a negative 11 as our strategy. What factors are we looking for? Because it's a plus sign here, it tells us both of those factors are the same, and we look in front of our linear coefficient, this is called the linear coefficient, to determine what sign they are. They both are negative. So it could be a negative 1 times a negative 24. Well, that would add up to be a negative 25. It could be a negative 2 times negative 12. Multiplies to give us a positive 24, but when we add those factors, gives us a negative 14. Not quite. It could be a negative 3 and a negative 8. Multiply to give us a positive 24, and look, when you add those, negative 3 plus negative 8 gives us negative 11. I'm done finding my factor pairs. I found the two that work. So to finish this, we need to include our greatest common factor, and in place of this trinomial, we have found that it's going to break down into, this was the result of the first term, so it must have been a t and a t, and as far as the second term in each binomial, a negative 3 and a negative 8, and with a quick check, first term we know, outside would be a negative 8, multiplying inside is a negative 3. That adds up to be the negative 11, and multiply our last term. So there's our final answer for that polynomial. In this last one, looking for the greatest common factor, there is none. It looks like an x, but there's no x in this term. So we have a leading coefficient of 1. Our procedure of then using a product here and an addition result here as our procedure is going to be the game plan. Temporarily, we can ignore this y squared because think about where the x squared came from. The x squared was the result of the first two terms being multiplied together. Well, this term is from our last term, just like this is from our first term. Not sure about the negative 4 yet, but where would a y square have come from? It would have been a y and a y. So having a variable here on the last term just means we have a variable in the last term of each of the binomials. And now it's system forward, just like we've been doing before. We have a negative 4. That means these factors, one is positive, one is negative. So we could have a negative 1 times 4. When we add negative 1 and 4, we get a positive 3. We're looking for a negative 3. All that means is reverse which factor has the negative. So a 1 and negative 4 multiply to give us negative 4 and add up to give us a negative 3. This then is our factor pair. That means we're going to put a positive 1 times y, and we could put the 1 or just leave it as y. It's understood to be 1. And then we're going to put a minus 4y for our second term in this second binomial. just to check this, first terms multiplied together, there's the x squared. Outside, we would have an x times negative 4y is negative 4xy. Inside, we'd have a 1 positive y times x is a positive xy. 1 and negative 4 are negative 3xy. And our last terms, positive times a negative, 4y times y gives us the negative 4y squared. So our final answer would be the following product of those two binomials.